Alright, so today we're going to talk about parallel and perpendicular lines, section 3.5. So we talk about slopes of parallel lines, slopes of perpendicular lines. Parallel lines. Parallel lines never cross each other. Two distinct lines are parallel if they both have the same slope or both vertical. The reason why we don't say that vertical lines have the same slope is because the slopes are undefined and you can't set two undefined numbers equal to each other. That doesn't make any sense. So they match the same slope and they increase and decrease at the same rate, or they're both vertical. Perpendicular lines. Perpendicular lines form a right angle when two lines, neither of which is vertical, are perpendicular if their slopes are negative reciprocals of each other. So here we have, these will form a right angle right there. There's a geometric argument to exactly why this happens. You get the negative reciprocal of the slope if they're perpendicular, but it's a bit beyond. It's in your book if you'd want to wish to look at it. We also say horizontal lines are perpendicular to vertical lines because, once again, we don't say they're negative reciprocals of each other because we can't take a reciprocal of an undefined number, or zero for that matter. So exercise 1. Find all the equations in slope-intercept form for the line passing through the point 4, -11 and parallel to the line 2y minus 14 equals -2 times 2 minus 2x quantity. So in this case, what we're going to do is we first need to figure out the slope of our parallel line and then use point slope form. So let me write that up here. So we're going to use y equals mx plus b to find our slope, and then we're going to use y minus y1 equals m times x minus x1 for the equation of our line. And then we want it in slope-intercept at the end. So first thing we need to do, we need to solve this line right here for the slope. So we need to put in slope-intercept form. So we're going to say 2y, and then we're going to move, let's just keep the 14 on the side for now. It's multiply through by -2. So I'm going to get -4 plus 4x, and then I'm going to add 14 to both sides, so I'm going to get 2y equals, and so if I add 14 to both sides, that's going to be -4 plus 14 is going to be 10, so I'm going to have 4x plus 10, and then I'm going to divide both sides by 2. I'm going to divide every number by 2, and or every term by 2, and so I'm going to get 2x plus 5, y equals 2x plus 5. Now this is our slope. So if they're parallel, m1 has to equal m2. So that means m1 was equal to 5. So m2 is equal to 5. Sorry, not 5. Excuse me. 2. I was looking at the wrong number. So if that's our slope, they have to have the same. So that means I'm going to use that slope in our new equation. So let me on the pencil that works. And so now I'm going to use the fact that m2 equals 2 as well. And so that's going to give me, use my formula up here. This is going to be my x sub 1, my y sub 1, for my point. And I'm going to have y minus, in this case, -11 equals 2 times, and we'll have x minus 4. So that's going to give me y plus 11 equals 2x minus 8. I'm going to subtract 11 from both sides, so I'm going to get y equals 2x, and this is going to be minus 19 because I'm going to subtract 11 from both sides. And this is the equation of our line, and it's in slope-intercept form. So it's y equals 2x minus 19. If you were to graph these two lines on the same, you'd have one that crosses at 5, and you'd have the other one down here that crosses at -19, and they'd have the same slope. They'd never intersect. All these pens that don't work, I don't know why I keep them. Exercise 2, find the equation in slope-intercept form for the line passing the point -14, -10, and perpendicular to the line 4x plus 8y equals 5y minus 5. So over here, let's figure out what the slope is. Once again, we're going to use slope-intercept form to find the slope. and then we're going to use point slope form to find the equation of the line. And so now I'm going to to subtract 5y from both sides and move the 4x to the other side. So I'm going to get 3y equals, move that 4x to the other side, negative 4x minus 5. And then I'm going to divide everything by 3. So I'm going to get y equals negative 4 over 3x plus, or actually minus, excuse me, 5 over 3. Now, here we have a fractional y-intercept. That really doesn't matter. What matters here is the slope, because m1 equals negative 4/3. So m2 has to equal negative 4/3, oops, the negative reciprocal. So it'd be negative 1 over negative 4/3. It's easier just to take this and flip it and change the sign, which will just be 3 over 4. All right. So, working from that, I think I'm grabbing from the wrong pile of markers today. Apparently not. Oh, that's better. I had my markers sorted into 2 piles, ones that worked and ones that didn't, and I think somebody switched them on me. So we have our second slope of our second line is going to be 3 over 4. It's going to be positive. So now I'm going to use these points. So I'm going to say I have y minus, and this is going to be my y1, this is going to be my x1, and that's going to be a negative 10, and this is going to be equal to 3/4 x, and then I'm going to have 14 here plus, because minus, well, I'll do that here in a second. And so I'm going to get y plus 10 equals 3/4 x, and that'll be plus 14, so I'm going to have positive 3 times 14 all over 4. And I'm going to reduce that fraction, so that'll be just, I'll cancel out a 2 from the 4 in here, so that'll be 2, that'll be 7, so it'll be 21 over 2. So now I'm going to have y, and I'm going to move the 10 to the other side, so it's going to equal 3 over 4 3/4 x plus, and that's going to give me a 21 over 2 and minus 10. Now I'm going to rewrite 10 as negative 20 over 2, or negative 10 as negative 20 over 2, so I have the same denominator. And then we have that equals 3/4 x, and so then that's going to give me what? Positive 1/2. All right, and so that is the equation and slope of our, this is the equation of our second line. It's in slope intercept form. Sometimes I'll ask for standard form, so be aware of that. Where the y-intercepts don't have anything to do with each other, they could be the same, they could be different. If the y-intercepts just happen to be the same on these 2 lines, well, then you have an incident where you have, they happen to they cross on the y-axis, and that could happen. It rarely happens, but it could. For parallel lines, the y-intercepts will never be the same, because if they were, they'd be the same line. So next it says determine the pair of lines below are perpendicular, parallel, or neither. So here we have, looking at this right here, we have our slope of our first line, m1 equals 4, and m2 equals negative 4. Well, here, these aren't negative reciprocals of each other, because one of them would have to be the reciprocal. So 4 is not the reciprocal. The negative reciprocal of 4 is not negative 4. So this is going to be neither. And they're not the same, obviously. Here we have m1 for b. We have y equals 3x minus 7 and y equals 3x minus 1 over 7. So 1 over 7 and 1 7 may think they're parallel, but remember we're looking at slopes. So m1 is 3, m2 is 3, and so that means that they're parallel. And the last one, same instructions. For exercise 3, determine if the pairs of lines below are parallel, perpendicular, or neither. Now looking at this once again, we have our first one, y equals 1/6 x minus 5, and y equals negative 6x minus 5. So even though the y-intercepts are the same, doesn't mean anything, we're just looking for the reciprocal slopes, negative reciprocal of each slope. So m1 is negative 6, or the same if they were parallel. m2 is negative 6. So we can always, if we want to check, we can always say 6 times negative 6, and that should give us negative 1 back out. So that means they are negative reciprocals of each other. So that means they have to be perpendicular. Mm-hmm. And the last example, on exercise 4, it says, determine if the two lines below a parallel, perpendicular, neither. And here they didn't give you like a simple, like it's already in slope-intercept form, so you can tell. Here you have to put it in slope-intercept form to find. So you do the first one over here. First thing I want to do is multiply everything by 2. So I'm going to start with 7x minus 4y all over 2 equals x plus 1. So I'm going to multiply both sides by 2 to get rid of the 2 in the denominator over here. Let's multiply by 2. And so I'm going to get 7x minus 4y equals 2x plus 2. Now I want to get all my x's on one side, so I can put it in the y equals mx plus b form, slope-intercept form, to find the slope. And so that's going to give us minus 7x from both sides. We get negative 4y equals, and this is going to give me negative 5x plus 2. I'm going to divide everything by a negative 4. And once again, we're not really concerned about the constant here. We're mostly concerned with the slope. So it's always good to take the time to reduce that fraction. But right now, we're mainly interested in the fact that we have 5/4 x plus, and actually be negative now, 1/2. So we're mainly interested in this first slope, m1, being 5/4. Thank you. And then the other one we're going to do and we're going to do, we get all the x's on the other side just like we did before. So I'm going to start out with negative 5y minus x equals 3x plus 5. So that's going to give me, I'm going to add x to both sides. So I'm going to have negative 5y equals 4x plus 5. And so I'm going to divide both sides by negative 5. Divide every term by negative 5. I'm going to get y equals negative 4/5 x minus 1. So that gives me my slope, my m2, to be negative 4/5. And we notice if we take 5/4 and negative 4/5, multiply together, we get negative 1 back out. So they must have been perpendicular. We got the same slope. They were parallel. If they were neither negative reciprocals of each other, or they weren't the same number, then it would be neither. Once again, the y-intercepts really don't matter. The only time they would matter if the lines were parallel and the y-intercepts was the same. It just means that you have the same line. But anyway, that's it for today. You all have a good one.